let's get started with this first. So, in this session, basically, we'll be talking about uh, what MLOps is in general. So, MLOps, as it consists of a whole ecosystem of developing a machine learning production model in a production-ready environment. What does production-ready means? It means that ML ops consists of machine learning, development, and then deployment. So you also need to have an end-to-end infrastructure which would handle this machine learning model, like to make real-time predictions using this. So how can we understand this first? So let's start with a simple example. It's a like a clear-cut example. Let's suppose we are working in a mobile factory where we have a live project running, which is detecting cracks on screens. So how would this work? Basically, the most simple technique would be a camera inspecting all the mobiles passing through the chain and taking the pictures. This camera would then send an API request to a prediction server, which we would have deployed in cloud or on an on-premise system. Then this prediction server would take its time to analyze, to predict, and then send back a data to the controlling software. Now, what this controlling software does is, let's suppose we have set a threshold of 75% accuracy. So let's suppose if we have 75, if the screen is having a crack and the threshold hits more than 75, then we reject that mobile screen. Else we let it pass through. Something like that. Like this is totally a general implementation which we can simple sober implementation which we can think about while building a this detection model. And as we all know, like ML models are not accurate always, and neither are human eyes. Like human eyes also miss out on what would happen, like passing through a model. Like even at looking at a screen, sometimes eyes would also catch the error in that part. So how is what MLOps is, and where does this ML model lies in the whole production system? Basically, in general, when the ML model is being deployed, tested in a real-time environment, the MLO code consists of only 10 to 20% of the whole infrastructure code which has been written. So it might either be on premise, on cloud, or on an edge IoT device, something like that. But so building a machine learning model in production, a machine learning system in production, is not a single step process. Basically, we start with like gathering data, building our model, but that's only the, let's suppose, 20 to 30% of the part. The rest 70% is keeping that model alive. As we all know, the data keeps on changing. Like the data which we have today might not be consistent with the data which we have earlier. uh, we can surely think about an example during the data from the pre-COVID times and the data during the COVID time. The amount of search and everything which were happening had a drastic shift when the COVID hit, when we were in the lockdown. So any machine learning model which was learning, let's suppose a machine learning model detecting theft or fraud uh, on an online system, which was trained during pre-COVID, and so the data might be something else, like the detecting of the what would be anti-theft and what corruption something would be in that scenario would be totally different from what we have been experiencing in the present COVID times. The search history, the user clicks and everything would have surged drastically as compared to what were present in before the pre-COVID times. So that's what the ML code is, the 20% of it, and the data keeps on shifting. So the main aim, the main focus is not building a production ready system, but is also to keep it consistent and reliable. Like the most important thing which you need to have with our system is its reliability. Like we need to have it to be accurate, and also it needs to be working fine. So with that, let's look into the infrastructure which the ML model consists of. Here you can see this is a basic reference from a research paper which was conducted by Dave Scully in 2015. So how do we start? Like what are the basic components of it? We have in this picture, you can see we have some configuration. We do the data collection, we do the verification of it, and also as well feature extraction and everything. You can see the ML code is in this small section. Like this. Hello. Okay. So ML code is in the this 20% of the section, as we can say, and we have the serving infrastructure, which is like the largest, like uh, where we can have this whole infrastructure, like having it deployed in cloud or somewhere, and or in on-premise system. Uh, and then at the end we have the monitoring aspects as well. So here in this through this session we'll be talking about what are the key challenges which we'll be facing while building this simple infrastructure as going forward. So there are several steps involved while building a machine learning in like a project in the production lifecycle. Starting with it, the the first and foremost one is the scope the project. So let's understand this with a total like case study, like where how we would be using these all the four parts of the machine learning part. Let's suppose we are building a speech recognition system, like let's suppose it's Alexa or Google something. So first we start with the scope of the project. We decide to work on speech recognition. So basically our aim is to work on the speech recognition system. Then the next thing is like decide on the key metrics, like how we would be evaluating the our end product. Will it be on accuracy or will it be on latency and throughput and something like that? Then we also need to estimate our resources and timeline. Same as we need, like in the agile methodology, when we start building a software, we need to do a requirement analysis about what we need to learn about, what are the scopes, how much feasible is the project, what are the requirements that would be present in that scenario. Next comes the data collection. To build a speech recognition system, we need to have accurate and consistent data which we would be testing it in the real world scenario. Like uh, let's suppose is the data labeled consistently, or let's suppose like I'm saying that hey Google, tell me the weather. So this weather can be something like let's suppose, would there be a pause between the question being asked and the ignition word being spoken? Like between Alexa, hey Alexa, and we have a pause, and then we are asked the question, and then again we have a pause. So how would the model be able to differentiate between which pause has the question part and which pause is just the user inference? It's nothing more than that. And then how do you perform volume normalization on the data? Like today's weather and hey, today's weather. There's a drastic gap of how much time we take to ask the question to the model. Next is the basic and simple most, train the model. So how do I modify the data to improve model performance? So there would be several aspects which come into the picture, whole ML concepts which come back into the picture about how do we train, like looking at the writing the perfect code and have doing the best hyperparameter tuning of it, feeding in the data, then training the model over epochs and evaluating a model, like having it increasing its validation accuracy, and doing some research out of the box, like trying to think of an another neural network architecture which would perform better than the neural network architecture which was supposed to be using, like using transfer learning on something as such. Then then feeding this all into the model and then moving like testing it out in the real world. And the last one is the deployment stage, deployment in the production. So in deployment, there are several aspects which come into play while we want to deploy. Like we need to have how much cost we can afford, like how much compute resource does our model need to do a accurate prediction, or it should be like how much fast it could predict and how much resource it would require to be efficient and decrease the latency which it would be needing. Then where the model is going to be deployed, or is it going to be deployed in an edge device, or is it going to be deployed in a cloud environment, or is it going to be deployed on the on system, like the system which we are using? So something like that, like we need to keep that in mind. So basically, how would a speech recognition system work? Like we speak, the voice gets captured to the microphone. Then we have a VAD module which converts this high frequency data into something which the computer can understand. Then so it's a local software configuration, and then we send this data, this VAD module speech part through a speech API to the model. Then the prediction server gives out a transcript of what could have been spoken in this. Then this again comes back to the front end code, and the analysis becomes, and then the search result is thrown out. So this is how like what a basic speech recognition system would totally work with. Uh, so moving forward, so then comes in the concept of drift, and like what is concept drift and what is data drift. As I mentioned earlier, like data is not consistent. Let's suppose like we have trained a model on some data, and eventually like the data trends shift, like as the example of folks browsing the web. The trend which was before the COVID era, and the trend which was after, which is after during the COVID era, was drastically huge different. Like the several times, like even a normal person browsing the internet got an issue of having like having a verification that verify that you're not a robo or something like that. Like this is not totally consistent with your browsing history, something like that. Like we folks started to use internet more and more as compared to the internet being used before the COVID era. So this is how like the data drift happens gradually. The drift would might be slow, like slowly trending towards something out of the box that the data what the model was trained on. So this is what is the concept. Then there are several software engineering issues which we face, like while building the um, MLOps production ready system. So I've listed it out, and let's talk about these in details first. So like the first question would be while building the system, these are the aspects which you need to keep in mind. So the first one would be is it a real time or a batch processing? So what is a real time or a batch part? It's basically means like let's suppose if you have a QR code scan, like basically a scanner which gives you the result instantly. So this would be a real time recognition system. Like even in the speech recognition, you send in your input and you get the output as it is. But in a batch processing system, it would be like you send in the data, you wait for the output, and you do have a certain bandwidth or certain latency which you can afford to have the output from the given model system. So it should not be instant, but in the real time part we need to have it as an instant system, something like that. Second is cloud versus edge or browser based model. So basically we have TensorFlow.js currently now, and which lets us run the machine learning models in the browser. And we again have TensorFlow.lite, which we use it and in the IoT based devices or some or on mobiles and every applications and Android applications as such. Then we also have cloud based models, like we deploy it in on a Google Cloud server or in Firebase, and we use this as an API point to connect with it. So, like, what is our requirement, and like, what should we be doing with this? This is how we decide about do we need to have a cloud versus cloud system or an edge or browser based system. Then the most important part which comes into the play is compute resources, like how much CPU or GPU or memory we can afford, and how much our model requires. Like if we provide our model with less GPU power, let's suppose if it's an image recognition model and it requires GPU to work, work, if it works faster with GPU than on a CPU, but then we would need to have a GPU system. We would need to have a GPU infrastructure which would help this model work. So if you do not provide this the required infrastructure part, the model would not perform as efficiently as it should. And also, if you do not have the budget to afford a GPU system, this would also need to be taken into account before moving on to those other things of the building the whole production ready system. So like these are basic software engineering issues. And the next one is latency or throughput. So it's like how much hit your server is receiving during a working time, like how much queries per second are being hit on the server. So it would be like uh, simple, like let's suppose if you have a traffic section, like you have a time zone time section where you have the most amount of hits on your server, and then you have something less. Then you can use a simple load balancer technique, something like that, which would increase the compute resources when the server is having the more number of hits, and you decrease it when you do not have it. So you need to decide upon it. Then Next is logging, like how much data, how much sections which you need to log into, like how much errors and everything, logs and data you need to have generated to understand how the model is performing on the data, or how the model is performing in the real time. So it should also be taken in account. And the last and foremost part, like this should have been the most top number of it should have the most priority, I think, like security and privacy which we need to have during our model. So like let's suppose some users do not want to have the data leave their premise, like let's suppose if it's a medical hospital system, or something like which the data is very private, or the user does not have the authority to let the data leave their system. So we need to understand how to build such models which would let like which would not let the data leave the on-prem system. So in such scenarios, we can have the models being deployed on the systems, or on an edge device, or something like the like end application where the real-time processing happens. Or if the data is allowed to leave, then we can have a remote server hosting our ML model, and all the queries and everything happening there, and the data being sent back, the processing is being sent back. So then again, we also need to take into account the latency or bandwidth which we support, and how much we have, how much we can afford to have a latency of, how much real time, like how much speed we need to have with our model. So these are the like general software engineering issues which we need. So basically, it's the requirement analysis which we perform before moving further into the next stage of like starting to build the whole infrastructure of the ML model. Next is first basically is deployment versus maintenance. Like uh, the real world is like once we deploy our model, the our work does not stop here. It's like you keep on the data, as I mentioned earlier, the data shift, the data changes in real time. So to keep our model consistent with the current real world examples, we need to eventually keep on training our model in loops. Like let's suppose we have a fresh batch of data which shows some trends which are not consistent to the batch of the data which was sent earlier to the model. So in such scenarios, what we need to do is we need to we need to retrain the model back, like for it to understand like uh, okay, now the trend is shifting. You need to understand that this out for this such user parts, like this for such browsing experience, this does not need necessarily have to be a robo. Or if the user is clicking quite fast, it's understandable that the user is having some let's suppose a very high-end performing system which allows him to do multitasking and something as such. So the model needs to understand. So the model needs to be retrained and retrained. So it's an ongoing life cycle. You train the model, you deploy it, you get the data, you again come back. So this is how the whole system would be. Next is moving forward with the common deployment cases. Like uh, what would be the like how do we deploy? So the most common deployment cases would be like new product capability. Uh, then we have automate and assist with manual tasks, or replace ML system. So like this is basically like uh, why do we need to deploy a model? The first one scenario would be like we have a new product or new requirement which has come into place, and we need to build something for that. So for such scenario, we'll have to do the requirement analysis for that, and then build a product for such, and then deploy it. So this is the first part. Then there's some tasks which are being done manually, but let's suppose if you have an engineer who says that, okay, hey, this task which you are performing, it's is taking a lot of time, but if you build a ML model which can help you with this to automate this task, you can surely go ahead, and it will save you a lot of time and effort while evaluating a task. So in such scenario, we again will have to assess the deployment scenarios and everything while building this system. Or if you have already a ML system which is working in the production and you need to replace it, so again you'll have to change your model, you change the whole code and everything, and then again build a model, and then put it into picture to put it into use. So this will be these are the three common scenario. The key idea is basically like we do not let the model take over at once. we gradually ramp up with monitoring. So it's like the child learning to walk for the first time. The child holds a hand and they slowly try to learn, try to move forward. They fall down, they get up, and then but still they keep on walking. So it's similar to this scenario here as well. Like we gradually let the ML model take control with an human assistance with the human, like something which has been passed through the human also goes through the human eyes. And then if there's some pitfall or something setback present, we roll back to the previously working system, the consistent working system, just like in VC version control. Like if we have a bad code which has been pushed into production, we roll back. We immediately roll back so that our code is currently working, and then we again gradually work up with it. Like we try to understand what could have gone wrong, something like that. So with this, like let's suppose as same with the visual our first model which was looking at the phone screens to detect cracks and everything in them. So like let's suppose we deploy ML model, we have trained it, and the ML model is looking at ML. So in such scenario, the ML model is looking at the code at the phones, and eventually also a human is also looking at that phone screen. So this part of deployment is known as shadow mode deployment. So shadow modes usually means that ML system shadows the human and runs in parallel. So the ML system would also be working, and then the human will also be looking at the output. But here, while the both the things are working in parallel, the ML system output not used for is not used for any decision during this phase. Like while it's in shadow mode, we do not use it. But the outputs might be used for verification, like what the human has detected and what the model has detected. These might be used for verifying like how much accurate the model is performing in the real time scenario. Like the general issue would be like let's suppose the model has been trained on perfectly captured images where the cracks are clearly visible, or the phone is present in the middle section of the image, so that the model is able to locate the phone in the given background and everything. But while working, while the phones move through the slide, uh, the images might not be always consistent. It might be that while it's taking the capture of the image, there might be a tilt shift, something zoomed in, or something as such. So this would definitely confuse the model if it has not seen such data. Then next is canary deployment part, as we see that. So we roll out to a small fraction, let's suppose say 5% of the total traffic which is being initially hit. So the less 95% is being handled by the human itself, but we allow the model which we have deployed to work with the 5% of the traffic coming through. So but still the model is in the monitoring phase, like we are monitoring the system as an if it is supposed to be. So but this 5% is gradually ramped up then. Like we allow the model to perform, like suppose we have started with 5%, then we eventually move to 10, 15, and all the way through, like up to let's suppose 100. So this would be like simple it's a canary deployment scenario where we allow the users to we allow the model to eventually work on its own and eliminating human from the whole background. So this is done to let the model overtake. So this is the overtake phase of the model, like it is trying to come into picture with as the like whole automation task and building everything. The model is coming into picture. And the last and the foremost is the blue green deployment. So here you can see in the image here, like this is the basic version of a blue green deployment part. So here we have images, then we have a router. So what we do basically is uh, let's suppose we have a model deployed, already deployed model, but we are trying to replace it with some other model, but are not sure that will this model be accurate as the previous model. Like would the current model which we are trying to build, the newer version, the green version of the model, and how good would it perform as compared to the previous model which was working, which we had in the working environment. So we start with this, like we have a router which has a switch. So the most general scenario would be like we switch to the greener version, and then we allow the model to make predictions, and we still monitor it. Like we keep on monitoring what the model is predicting and how it is performing as compared to the previous model. Let's suppose in some scenario, like the greener version is not making as accurate prediction as it should be. So we need to fall back to a safer side. Like we need to fall back where we can have a yet working production system, which was consistent, like which is consistent, was previously reliable. So we can switch back and try to improve the current model which we're trying to deploy. So in such scenario, what we do is we just route our queries to the older version, and then we start working on this newer green version of the model and try to again improve it. And again, then using the router, we change the API queries to this again. So eventually, like we try to fixate on it. We try to so it's this blue green deployment model helps us to build. It's a easy enables us to roll back. Like we are able to switch to a consistent version if we are not able to have a better output from the older model which we are using. Then comes in like the degree of automation. Like you can choose to stop, like basically how much amount of automation you want to have in your system, like how much assistance does the AI need while working. So the so in human only mode, like let's suppose in this part, like if the part is in human only, as we mentioned first, like we have a human looking at the images, the phone screens manually, and then trying to understand like if it's a crack or not. Then we eventually move up. So what happens is after the human mode we have the shadow mode. So here we said that uh, here we said that we can have the model having shadow mode. It's working in shadow mode. So in shadow mode, what we understood was the model and the human works parallelly, but the model's prediction is not used while doing the output. Then moving from the shadow mode, we have the AI assistance, where we have the AI also helps. Like the AI's input output is passed through a human to verify. So in such scenarios, the human understands like is the model doing good or not. Then we have partial automations. So the human in the loop, like the human stays in the loop until the partial automation phase. Like we need to have, so you can choose to stop before getting to full automation. Like you can say that hey, I do not want to have a fully automated system because not every time the ML model is reliable. So we need to keep human in the loop in some part of the automations in the scenarios. So in this part, like the human stays until and unless it's a partial automation. If we move to full automation, the human from the loop is eliminated, and it's a fully AI system. Like the AI is working, trying to understand whatever you need to do. The AI does that. Then we have the three metrics, like uh, at the end of the phase, as we saw here, like in the less part after deployment, we also do need to have some understanding of like how the model is predicting, how the model is working. As I mentioned earlier in the earlier slides, like building an model in prediction is building a model is only 30 to 20 to 30% of the work. Keeping the model consistent with the growing trends is the most iterative process. Like you need to understand like what's happening with the model, how is the model predicting, and how the user data is changing and everything. So in this first part, like we have a let's suppose how do we monitor it. So there are several metrics we can keep into account while we can take into account while monitoring the part. Like let's suppose we have a monitoring dashboard where we have a server load or fraction of non-null outputs, or something. Let's suppose fraction of missing input values. Like let's suppose there was something given to the model which the model was not able to give any output about. So it would show us like what's going wrong. So we brainstorm the things that could go wrong. Like we try to initially assess like these are the scenarios that might creep in while the model is running. And then again we brainstorm a few statistics or metrics that will detect the problem. Like this dashboard would help us analyze like how the model is predicting, how much is the model behaving correctly, or it is okay to use many metrics initially and gradually remove the ones you find not useful. Like let's suppose you have a dashboard, we have we're monitoring several aspects of the model, but all those aspects do not come into play every time. So eventually, like while you have eliminated those aspects of the model, like let's suppose you have eliminated the fraction of non-null outputs from the model, like you know that your your model will not throw this kind of error or something, then you can eliminate those. So there are several metrics which come into play as it's mentioned here. The first one is example. So how can we track those? So for software metrics, it could be like memory, compute, latency, throughput, or server load. So it's like how much it is the system getting, how much parts, like how much memory is it consuming, how much compute power is it consuming, how much time is it taking to process the given batch of data or something like that. Then moving forward, why we have the input matrix, uh, where we need to understand what is the input, what type of input is coming to the model. Like let's suppose we have what's the average input length, what's the average input volume. Then let's suppose how much numbers, like number of missing values which are coming to the to the model. And then uh, let's suppose in the scenario of a image recognition system, what is the average image brightness that is coming into the picture. Like if it's a very dull image, or is the model performing bad because it's receiving dull image, or is the model performing good is because of having a perfectly well captured well lit image because it's able to recognize it correctly. then then we have the output metrics to measure, like number of times where we returned a null value, and the number of times user wrote search, something like a time so user switches to typing, something like that. So it is like, let's suppose you are using a Google recognition system or Alexa on your phone, but the model is not able to quite understand quite perfectly what you're trying to say. So in that such scenario, you switch to typing instantly because you need to have something like you need to have your output. You need to have a work done. So you need to keep an account that the person triggered the voice recognition system, but the voice recognition system did not perform as he expected. So he switched to typing. So they switched to typing. This is like these are the monitoring aspects which you need to keep into understand undertaking while measuring the efficiency of the system. Next is just as ML modeling is iterative, so is deployment. As we all know, like we train our models for some epochs, then we evaluate it, and again then we do some hyperparameter tuning, and then we again move forward, like understanding like what type of architecture which we can choose to build this model, to build a good model. So even in the scene of deployment, this comes into picture. Like the deployment is also an iterative process. So the basic thing is in the ML model, we had the data and everything. We experiment, we do the error analysis, then we again train the model, then we again do some experiments. Similarly, is the case of deployment. Like we deploy something, then we monitor the traffic and QPS and everything. Then we do performance analysis, like how well is the model performing, how fast is the user trend shifting, something like that, and then again do deployment of the part. So this is an iterative process to keep the model alive, uh, to keep the model consistent with the current environment. We need to have an iterative process to keep our to update our model. So as you can see in the picture, we have the model, then we create, plan, package. So this is the development part, and then with the operation part, you configure, you release, and you monitor. And again, in the monitoring dashboard, we can have like set threshold for alarms. Like let's suppose if a server load is increasing to a certain threshold, we can set an alarm to. Or if the model is predicting too many null values, like we hit a threshold where we suppose that, let's suppose our model is supposed to have an accuracy of like we can handle null pointer values of around 5%, but we move more than 5%, then we set an alarm that okay, now the model is really degrading its performance and it is not able to keep up with the queries it is being sent to. Then in such scenario we need to have some alarm systems in place which could notify us about our model becoming out of the becoming not consistent with the part. Then we adapt the metrics and threshold over time, then we try to adapt it over and then try to understand. So talking about maintenance, how do we maintain the part? So deployment is one part, then again the maintaining is the other part. So there are two aspects which you can use. We can use manual retraining or automatic retraining. So in manual retraining it's like you are having the data, you retrain your model with that data, take a downtime of some part, then you manually retrain it, and then you again push it into production. The other part would be automatic retraining. Would be like let's suppose if you have set up a data set limit of, let's suppose hey, if I get 10,000 more new data sets, I'll have to retrain, because these 10,000 data set might need to be handled while the model is running. So in such scenario what we do is we when we hit our 10,000 data set limit, we automatically retrain our model. Again, we need a downtime for such scenarios, and then gradually move up with the pipe. So in the deployment section we have a pipeline monitoring part, like let's suppose while building a, we need to monitor basically while using a speech recognition system. We have audio. While training it was simple sober that we had a data set which was containing some audios. We trained our speech recognition model, then we got a transcript. So basically it was X to Y mapping something, some sort of. But what happens in the real time scenario is some cell phones might have a VAD audio clip differently. Like let's suppose if you have a mic in your mobile phone, so these mics do behave differently. Like the voice being captured through different cell phones would be totally different, because the VAD module which is present in these phones are might try to produce different types of sound, but the model has not like listen to these sounds. So it might happen that the model might not be able to recognize what the voice is about, what everything is there. So the speech recognition system might fail. Or let's suppose we have a user profile example. Let's suppose we have a user data, and then we have a user profile, and we are making a recommender system. So the user data has some metrics. Let's suppose, is the user owning a car or something like that, or is he buying buying a watch. So we make a recommender system on that aspects. So we need to have a clear understanding about what the user is trying to search. Let's suppose if you are searching for a watch and you're getting recommendation for uh, what, let's suppose a table lamp. So these recommendations do not correctly match with it, right? Like what we are buying, what we are currently purchasing, and what the model is, what our recommender system is trying to us to uh, recommend us, is not totally consistent. So we need to keep that in mind as well. So as we mentioned, we have three metrics to monitor: software metrics, input, and output. So how do these metrics usually change? Like how fast do they change? So user data generally has a slower drift, like your taste about, let's suppose we as a user have a taste of some types of objects which we like to purchase. Like someone likes a chain wristwatch, or someone likes a belt wristwatch, and someone likes a silicone wristwatch. So these tastes do not drastically change. It might take some time. Let's suppose over a year or so your taste might change about it. But in enterprise, when it's a B2B application, like business to business application, the shift can be fast. Like the user trends and everything which we are analyzing and seeing, this can be very drastic in an B2B application. So yes, so that was all about, like, this is all what I had talk about. It's basically a general introduction about it. Like if we want, we can have other session where we can have a hands-on lab about talking about what we need, like totally pushing a model into production and analyzing that and everything. So